Hello guys. So in this exercise, we are going to perform the static structural analysis. So you can click on static structural analysis and drag and drop it into our project schematic. So in the static structural analysis, you can see various steps starting from engineering data, geometry model, and eventually finishing in results. So in the engineering data, step, we are going to define the material property. And in the geometry, we are going to draw the geometry. In the model, we are going to generate the mesh and set up the conditions and the load, and we are going finally to solve the problem, and we are going to take the results. So first, I'm going to start with engineering data. So double click on engineering data and you can edit. Initially, the predefined material is structural steel. So I'm going to define a new material. So click here to add a new material, and I'm going to type material 1. Enter. And you can see a question mark. This is because I haven't specified the nature of the material. Okay, so we have liner elastic in the left side. You can see various material properties, and in this exercise, I'm going to consider liner elastic, that is trophic elasticity material. So you click on strophic elasticity and drag it and drop it into material 1. Now you can see we need to provide two inputs, the Young modulus and Poisson ratio. So the first one is Young modulus. I will type 210 E 210 E 9 210 E 9, and the Poisson ratio I'm gonna type 0.3. So you can type the values, and you can after that click enter. Now again you go to the project, and you can see there is a question mark in geometry. So here the next I'm going to the geometry. So I will create our geometry. So right click on geometry. So you can create geometry using two options. The first one, as we learned, the design modular, and the second is space claim. So here I'm going to use the design modular. So you can click on design modular. So design modular is open now. As you can see here, we have three planes, XY, ZX, and YZ. So here I am going to choose XY plane, and right click on XY plane and look at. So now I can see our plane. So I can now view the in the normal direction. So this is X and this is Y. You can use the scroll button in the mouse to zoom in and zoom out, and you can click on control and scroll, and you can move. So now I'm going to model. So go to sketching and draw. So draw a line. So here you can see various sketching tools. So in this axis, I'm going to draw a line. So you select a line. As you can see here, that it's in the origin. It will be B, and in the line C, as you can see. So I put the first point on the origin, and I choose this line. You can draw a horizontal line. Next, I'm going to mark the dimensions. So go to dimensions and select general dimensions for this basic exercise, and click on the line that we made. And here we will change the dimension. As you can see here, it's in meter, so we need to change the units to millimeter. How So we go to units, millimeter, and now the units are changed, so it's now in millimeter. Now the value of H1 is 500 millimeter. Enter. So if you want to zoom in to see our line, so now I have created a sketch. Next, I'm going to generate a line from sketch. So you can do that on concept, line from sketches, and select this line, hit apply. So now I have created a line from sketch. Next, I'm going to define the cross section. So go to concept, cross section. I forgot to generate the line. As you can see here, it's still not generated. So I need to generate the line. So now it's okay. So I go to concept, cross section, and choose a circular cross section. And the cross section is circular, and the radius is 16 divided by 2. 16 divided by 2. Hit enter. Because the diameter is 16, the whole diameter is 16, so the diameter it will be 8. Okay, you can now click generate. Now you can click on this plus part, one part, one body, and select this line body, and choose the cross section here, circular one, the one that we have made here, circular one, line body, cross section, circular one, and after that go generate. Generate is very important. We need to generate every step that we do in the design modular. So we zoom in, control, scroll. Okay, okay. So you can see this is our model. So if you view the cross section, Then go uh, to view cross section solids. So as you can visualize the a cross section. So as you can see, it's a circular cross section. We close this, and after that we go model. So right click on model, edit. Mechanical is opening now. First thing I'm going to do, I'm going to choose the material. So I go to geometry, line body, assignment, structural steel, it's predefined. So I will choose material one. And now after we choose the material, so we go generate our mesh, right click mesh, generate mesh. So as you can see, we have our mesh now. If you want to refine the mesh, you can add sizing, or add by here insert sizing, and it change the element size. But I'm okay with this mesh. So the next, I go to the static structural here where I apply the boundary conditions and the loading. So I will add here fixed support, and here force of 20,000 Newton. So first I will go insert fixed support. I will choose this vertex. So I choose only one point, apply, and next I insert a loading, so force, and I will choose this point, the end of this line. And now as you can see, I need to define the direction of this force. So I will choose component, and I want it to be in the positive x direction. So it will be 20,000 20,000 Newton. As you can see now, it's in the x direction, positive x direction. Okay. After that, we go to solution. We want to total deformation. Also, I want to see the beam tool, so I can see the direct stress, minimum combined stress, maximum combined stress. And after that, we click on solve. So here is the result of the total deformation. So here is the minimum at the fixed support and the maximum at our pulling force. As you can see, the unit is millimeter. And as you can see, this is the direct stress, minimum complaint stress, and maximum combined stress. And again, this is the direct stress. And this direct stress is the same in the whole section, because this is a single body subjected to a single force. So the stress will be uniform throughout the the section. And also you can go to images, and you can select image, and you can select image to a file, or you can animate, as you can see, and you can animate also the total deformation, and save the video file. So that's all. I hope this video was helpful, and thank you. And please like the video and subscribe. Thank you. See you next video.